This episode of Rhizome is brought to you in part by the Synthesis Security Group and Fuzzy Wuzzy Signal Processing, a venture of Ian Swanke. Copyright 2026. All rights reserved.
Welcome to this explainer. Today we are exploring something absolutely mind-bending, the universe's hidden API, looking at wave physics and simulated reality. Now, to kick things off, we're going to look at a true classic of scientific history. I'm talking about Dr. John Shive's iconic Bell Labs wave machine demonstration. But hey, we aren't just looking at this as some cool retro teaching tool. No way. Instead, we're going to see how this very machine actually acts like a window right into reality's underlying source code. It literally gives us a visual representation of the unified mechanics that run our entire physical world. Okay, let's dive into this with a bit of a mystery. Have you ever wondered why a massive electrical radio transmitter acts exactly, and I mean exactly, like a child's playground swing? Seriously, why do physical systems that operate in totally different domains behave identically? Well, to really understand this, we have to look way past the physical materials themselves. We have to look past the metal, the electricity, the rubber, the whole shebang, and really investigate the mathematical engine that's running under the hood of our reality. So that underlying engine, it's entirely built on something called linearity. Basically, it's a property of systems that are governed by linear differential equations. Now, the easiest way to think of this is like a shared mathematical language for the entire universe. It dictates exactly how acoustic, electrical, optical, and mechanical waves all operate. And because they literally all speak this exact same mathematical language, they exhibit identical foundational behaviors, no matter what physical stuff they're actually made of. To really lock this concept in, let's just consider a mechanical wave traveling down a physical wire, and compare that to an invisible electrical wave pulsing through a transmission line. Despite dealing with vastly different mediums, tangible metal on one hand versus an invisible electromagnetic field on the other, Dr. Shiv's demonstrations proved that the underlying mathematics are completely identical. It's wild. The universe honestly doesn't care about the medium at all. It just executes the math. And because the universe runs on this clean, linear math, we get incredibly elegant phenomena like superposition. That is simply the ability of waves to pass right through each other without interacting or corrupting each other's underlying information. It's the exact reason where incredibly complex, multi-layered optical interference patterns or super dense radio frequency signals can just coexist perfectly without totally collapsing into chaotic noise. These waves propagate cleanly through the exact same space at the exact same time. Now, another totally universal feature in this mathematical toolkit is impedance matching. This is the ultimate mechanism for maximizing energy transfer and minimizing reflection. You can think of it essentially as a story of energy just trying to reach its destination perfectly. Whether that energy is moving through a mechanical dash pod absorbing a physical shock, or it's light passing through a specialized optical coating on your camera lens, the end goal is identical. The universe just wants that energy to propagate smoothly. And impedance matching acts as this sort of universal adapter, making it happen seamlessly across every single domain. Now, what's really interesting about this slide is how the inverse square law shows up across these different domains. In acoustics, energy dilutes over a spherical surface area, the classic 4 pi r squared, which results in a mathematical falloff of 1 over r squared. But notice how point source magnetics perfectly matches that exact same 1 over r squared falloff. Sure, a magnetic dipole falls off a bit faster at 1 over r cubed because the poles interfere with each other, but the pure point source behavior aligns perfectly with sound. So, why does this happen? Well, it's just a geometric inevitability. Our three-dimensional space literally forces the energy to dilute evenly over a sphere as it spreads outwards. So taking a macro perspective for a second, it's completely mind-blowing that nature clearly uses the exact same math library across vastly different physical domains. From the microscopic vibrations of atomic subparticles all the way up to massive stadium-sized acoustic sound systems, they share and obey the exact same wave equations and inverse square laws. It's basically as if the universe has this master rulebook, like a foundational physics API, that absolutely everything, regardless of its scale or material, must strictly follow. No exceptions. Which brings us to a massive, totally perspective-shifting philosophical implication. Think about it. If nature operates using a single unified math library, well, it looks suspiciously like software. And if the universe really acts like software, we can hypothesize that it operates on three logical pillars of computational architecture. Those are code reuse, computational efficiency, and resolution limits. So let's break these down one by one to see how our reality remarkably mirrors a simulated engine. First up, we've got code reuse. Just think about it from a software developer's perspective for a minute. If you were building a simulated universe from scratch, you definitely wouldn't waste time coding totally unique, bespoke physics rules for sound, and then write another unique set just for light, and then yet another for electricity, right? No way. You'd write a single, robust physics engine. You just tweak the parameters, things like density or permittivity, to alter the domain. So all those cross-domain similarities Dr. Shuv demonstrated, they're effectively just reused class instances of one universal API, calling the exact same wave functions over and over. So the crucial point is that beyond just reusing code, this whole setup solves a massive problem: computational efficiency. Remember when we talked about superposition earlier? Well, mathematically speaking, simply summing up linear wave solutions is computationally really, really cheap. It's vastly more efficient to process than trying to continuously calculate nonlinear, chaotic interactions everywhere all at once. By running on linear principles wherever it possibly can, the universe essentially conserves its computational resources. It is highly, highly optimized for efficiency. And finally, we arrive at the third pillar: resolution and constants. Our universe has these strict, unchangeable boundaries and limits. We're talking about the speed of light, the gravitational constant, Planck's length. Now, in a standard physical model, these are just accepted facts of nature. It is what it is. But if we view this through the lens of a simulation, these constants look exactly like the ultimate clock speed or the resolution limits of a digital system. They are the strict boundaries where the simulation's math either completely maxes out or it has to switch to a totally different processing mode, like quantum mechanics, just to handle the computational load. And this brilliantly illustrates why we brought up Dr. Shuv's wave machine in the first place. It brings us right back full circle. When you see a resonant circuit in an electrical radio transmitter behaving exactly like an acoustic organ pipe or a child's mechanical swing, it really points toward a universal design constraint. We are literally witnessing the strict, elegant efficiency of a universal engine at work. The math doesn't change across these domains because, well, it simply doesn't need to. The code is already perfectly optimized. Which leaves us with one undeniable, mind-bending question to ponder as we wrap up. If our reality is truly governed by reused code, optimized for maximum computational efficiency, and bounded by strict processing limits, are the universal constants just the clock speed of our simulation? It's a lot to think about. So keep your eyes open and keep looking for the code hidden in the world around you.
Now available exclusively on Amazon Kindle eBooks, Rhizome Summer 2026, a collection of essays, Rhizome Fall 2026 Book 2.